Welcome back, everybody. A couple of announcements. The most important one is what we're going to be doing with the quizzes. We will have our quiz today like we normally do, but in the future it turns out that having the quizzes on 2 days is very difficult to keep track of. And so what I'm going to do is from henceforth all of the quizzes will be given on Wednesday. And that means that if you're not live, you will be taking it via Canvas, okay? The people who are here in the class will take the quiz on a piece of paper, but if you're not there that day because it's not your day to be there, or because you've been ordered to stay home or you're sick, then you will take it on Canvas, okay? Be sure to check yourself off. So, quizzes from henceforth after today will always be on Wednesdays. And no more Monday quizzes. And they will not include the material that was covered on the Monday before them. They will still cover the material from the previous week. The Monday, Wednesday, and Friday from the previous week, okay? So that means, I think for you folks, I think you'll be taking it on Canvas next week. I think if that's how it works out. So either live if you're here, but if it's a video day for you, you will take it on Canvas. And what I'm going to do is I'm going to put a dummy quiz on Canvas. What is your instructor's name? What is the name of this course? What else could I say? What is today? Something like that. Between now and next Wednesday, you folks should, and everybody in fact, should try to take that quiz just so you know how quizzes are done on Canvas. Some of you may not have worked with Canvas. All you have to do is it's www.prosper.edu. This is how you get to Canvas. Not that I love it, but and you will see a big block for this class you can push on, and in the sidebar on the left you'll see quizzes, and if you click on that you'll see this the dummy quiz this next week, and then next Wednesday you will see it. Now, there is a time limit. You must take it between 10 and 10:30. You are expected to have this period open. Even if you are not physically here, I expect that you are able to do something during that. And it will be open from 10 to 10:30. If you start it and 10:30 passes while you're in the middle of it, it will take what you have answered, lock you out, and that is the result for your quiz. So be sure and sign in enough ahead of time so that you complete it. I mean, it's still going to be 4 questions. It takes about 5 minutes, if that, to complete it, but you must do it between 10 and 10:30, okay? All right, so for this group, this will be the first time you do it online. And that way I can pick up. Now, I won't be using the grading scheme of Canvas. I don't like the way Canvas stores grades. It's really crazy. And by the way, when you finish a quiz, it tells you what your score is. It tells you what your score is. You should write that down. You should write down what your score was so you know what it was. Okay? This is so if people are ordered to stay home, or if people have to stay home or something, they can still have a way of taking the quiz. This business of me having to mail the quiz to individual people, that's going to stop. All that happens is, you let this go too far, all I do is I become an email machine. And they're not paying me the big salary for a full professor to write bunches of emails. That's not an efficient use of my talent. So, any questions on it? Okay, gosh. I urge you, again, when you are out there in the real world, to wear your mask at all times. Even if you're in the bathroom, I am amazed that people seem to think it's okay to take your mask off in the bathroom. The bathroom is the worst place for you to remove your mask. You take your mask off. If you're asymptomatic and infected, you infect the entire bathroom and leave that residual there for maybe 15, 20 minutes. Anybody else gets in is exposed to it. If anything, the most important place to keep your mask on is when you're in the restroom. And you should have it on at all times, even if you have a roommate. I already know of one case where a roommate is infected. I don't know about the other person. This virus doesn't recognize the fact that it's your roommate or your friend or whatever. Your roommate's just as likely to be infected as anybody else. You should exercise social distancing with a roommate and be especially careful if you're sharing an apartment with a roommate. Really be careful. All right, that said, I think I was talking about Copernicus's theory, was where we finished up. And the Copernican theory, huge change. According to Copernicus, the Earth is not the center of the universe, the sun is the center of the universe, okay? And he publishes this around 1543, after he's dead, and because he doesn't want repercussions from the church and so forth. And he has to put back in tiny epicycles, and he has to put in eccentrics. But when he does that, he gets it to work. And when I say he gets it to work, I mean he can go to the library, look up the position of Mars perhaps over 2 or 3 years, and get agreement with that when he sets up his model, which means presumably if he sets it up with where Mars is today, he can predict with accuracy where Mars will be 2 or 3 years into the future. All right? Now, so it works as well as Ptolemy's. It's radically different. This is a classic case in science where we have two theories, Ptolemy's theories and Copernicus's theories, both of which work equally well in predicting where the planets are going to be, but they are absolutely different in their explanations. Ptolemy says the Earth is sitting still, the sky is actually turning, the planets are doing something like this, the sun is going around the Earth, and so on and so forth. Copernicus says, no, those are all illusions. The sun is sitting still. The Earth is turning on its axis. So that the motion of the sun during the daytime is an illusion. The rotation of the stars are actually sitting still. The Earth is turning on its axis, and so forth. Radically different. But both capable of predicting the positions of the planets and everything else. How do you sort that out? They can't both be right. They cannot both be right. Well, what it comes down to is you have to have more data, and we'll talk about that very shortly. But first of all, let's look at what happens when Copernicus publishes this. Is that it accepted? And the answer is absolutely not. Absolutely not. I don't care that if it agrees with the data. I don't care. The objections to this are numerous. All right? First of all, and most importantly, we are not at the center of God's universe. Philosophically, that is a big one. All right? That is a big one. Where are now heaven and hell? We're no longer the center of God's universe. In fact, let me ask this of you. According to Copernicus, the Earth, this, is a planet. This planet has life on it. Therefore, if the Earth is a planet like Mercury, Venus, Mars, Jupiter, and Saturn, what could you conclude about Mercury, Venus, Mars, Jupiter, or Saturn? They could have life on them. You just got your butt burned at the stake. Giordano Bruno was someone who suggested this in the years before this, and they burned him at the stake. They don't just kill you, they kill you horribly, screaming at the top of your lungs in front of everybody else, so that nobody dares to think the way that you did. They want to be sure that nobody questions the way we know it's supposed to be. Yes, one of the things that comes out of this is the possibility of life elsewhere in the universe, and we cannot have that. God is concerned with humans only. There are only humans, nothing else. There are also scientific objections, like what keeps the earth moving? It was believed that for something to continue to move, you had to keep pushing on it. In all of our travels, and the Greek travels, and all of the travels of everybody, 1543, Columbus said, travel to America and all that. No one ever saw anything pushing on the earth to keep it moving around the sun, and no one certainly saw anything to keep the earth turning on its axis. So how does it keep turning on its axis and moving around the sun? Not acceptable. Not acceptable. Okay? What keeps the earth moving? Why aren't we blown off? We will see that, according to Aristotle later, that the entire universe would have to be filled with air. That the belief was you could not have a vacuum. The vacuum had not been discovered. The absence of air was not possible. It was believed everything had to be filled with air, including all up there. If the Earth were going around the sun, it would have to be going 67,000 miles an hour, which means there would be 67,000 mile-an-hour winds blowing us off of the Earth. Now, we just had a hurricane come through with 150 mile-an-hour winds down in the south. Can you imagine 67,000 mile-an-hour winds? They're not there, so, hey, the Earth can't be moving, right? That can't be possibly right. Also, why aren't we thrown off? If the Earth is turning on its axis, we know that if you're on something that's turning and spinning, you put something on a pottery wheel and spin the pottery wheel fast enough, it will slide off and be thrown off. Why aren't we flown off into space if the Earth is turning on its axis? Now, we know nowadays it's gravity. But they didn't know about gravity back in 1543. They didn't know about that. They didn't know about that. So there were a lot of objections to it. There were a lot of objections. Nonetheless, it worked. And so if you were an astrologer and you had to predict the position of the planets for a client, say, well, this is easier to use because it doesn't have the equant. So in secret you would use it, yet you would acknowledge publicly that it can't really be right, that it's just a convenient way to calculate the positions, but it can't truly be correct because of all of these various objections. So it was not generally accepted. It was not generally accepted. Any questions or comments? Well, how do you solve it? How do you sort it all out? Well, what you need is the following. When you ask, how do we know that either Copernicus or Ptolemy's model is correct? The acid test is, does it fit the data taken by the Babylonians that's recorded in the library? The Babylonians watched several of the planets over years, record the positions. If you can reproduce that motion with your model to sufficient accuracy, then we say it works. But the Babylonian data is now like 1,500 years old. And technology obviously improved since the time of Christ up to 1543. And so what happens is the way to sort this out is somebody needs to go and remeasure the positions of the planets with higher accuracy. We need somebody to remeasure the positions with higher accuracy. And the person that does that is Tycho Brahe. He knows that this argument exists between the two methods. He knows the way to try to sort it out is to build a planetary observatory. Now, an observatory doesn't mean you have a telescope and a dome and, you know, what you think of as an observatory, okay? An observatory means a place where you watch the heavens. And they didn't have telescopes in this time. So essentially, you can imagine making a really long tube, like, imagine taking the tube in the middle of some Christmas wrapping and sighting down through the tube. And if you mount that on something so that you can sight through it and sight the planet and then make a location notation, that's how you would record the positions of the planets. But observatories take money. Nowadays, you go to the National Science Foundation and you beg for money. Who can tell me back then, if you wanted an expedition or something like Columbus, where did you go to get the money and the equipment you needed? Real loud. The king and queen or the grand poobah, whoever the leader of the country was. In Europe, it would have been the king or queen. He goes to the royalty in Denmark. He goes in Denmark. And he convinces them that building an observatory to observe the planets and make a record of their readings would be a thing of stature for the country of Denmark to do. And they agree to it. And so a planetary observatory is ultimately built. All right. Now, the dates are approximate. 1576 is often the date that's quoted, but, you know, this is something like 25 or 30 years after Copernicus's publication. And what they do is they make careful observations of the planets. And their observations are 4 times more accurate than the older Babylonian data. Now, I do not know how the Babylonians did it. But first of all, we have to introduce the idea of a circle of uncertainty. If this is a location given in the library where the Babylonians said that they observed a planet on a certain day at a certain time, there's actually a region around that. This is a region of uncertainty. So this means this is like a bullseye. You know, when you throw darts or you shoot arrows, they have a target, and there's a black spot in the middle, and that's the bullseye. Okay? Well, if you make the bullseye big enough, anybody can hit it. Okay? I mean, if you make the bullseye as big as the entire side of the bar, even a drunk guy can somehow hit it with a dart. To separate out the champs from the wimps, you make the bullseye smaller. So this was the bullseye of the Babylonians. And so if you said, well, is Ptolemy's model working? If Ptolemy's model says it was there, that P is for Ptolemy. Copernicus's model might say it was over there. They're both inside the circle. They both hit the bullseye. And so you say, yep, we have agreement. Notice they don't agree with each other. They're off. But they both are adequately, they're good enough in order to hit the bullseye. So that circle is the Babylonian circle. But if you go to Tycho, that is Tycho's circle. It's about 1/4 the size. It's a hell of a lot harder to hit. Okay? Tycho's circle of uncertainty is much smaller than the Babylonian circle. And in particular, not only does it get more accurate data, it's done faithfully day in, day out, whenever the sky isn't covered up, obviously. And he gets particularly good data on Mars. He gets a string of observations about where Mars is that's really very accurate. It's quite impressive. It really is quite impressive. So, what do you notice just about the way I happened to draw that? You see that Copernicus is not hitting the target, and neither is Ptolemy. So what you do, once you have this data, is if you have this more accurate data, then it makes sense to go into Copernicus's model. And how many numbers did I say there were that describe each planet? How many of them were there? How many? 6. You retweak those numbers. You go and you readjust those numbers so that you can bring Copernicus' predictions inside the smaller region of uncertainty. And what he finds, what Tycho Brahe finds, is that no matter how much he plays with Copernicus' model, cover that nose. Don't play with it, okay? You shouldn't touch this either, okay? Avoid touching it. The virus can collect outside there. You touch it, you touch your face. He can't get it to work. Especially with this data from Mars, no matter how much he adjusts those parameters, we cannot get Ptolemy's model to work. And that is the ticket. Ptolemy's model is what has been taught for 1,500 years. Now I can tell you, you can't get Copernicus' model to work either. No matter how much you screw around with the parameters of Copernicus' model, you cannot get it always within the bullseye. It eventually wanders out. As long as you make the bullseye big enough, it can wander around, and that's fine. But you make that bullseye too small, you can't hit it. So he finds that with the new observations, that Copernicus cannot fit the new data. Cannot fit the data. Well, that's no big deal. People would have said, well, we could have told you that. Come on, we know that the Earth is the center of the universe. This idiot says the sun is. That's obviously wrong. So, fine, okay. But the trouble is, Ptolemy's model cannot fit it either. And that is a major problem. This should be, just so we're absolutely clear, the new data. You can fit the old data. Either. I'm putting exclamation marks on that. Because this is in-your-face evidence that what has been taught by Ptolemy and the Catholic Church for all that time is not correct. It's the first evidence that the model taught by the church for the last 1,500 or whatever years is wrong. We finally have proof that the teaching of the church is incorrect. Now, what else is going on around this time? This is the time when the Catholic Church is starting to lose power and its grip on people. People are allowed to think differently. Again, what is this period in history called? Da Vinci's period and so forth. What do we call this? The Renaissance. The Renaissance. People can start to question things that have had to be held on faith under pain of death or excommunication and so forth. It is a wonderful period. So, neither of the models works. Neither one. Well, what do you do? Well, what Tycho does do is he comes up with yet another model. A new way. Now, I must stress at the outset that Tycho's model cannot explain his own data, and he knows this. But what he does is he combines the best of both Ptolemy and Copernicus, and so what he says is that the Earth is the center of the universe. So we go back to this. Okay? It's geocentric, not heliocentric. The Earth does not turn on its axis. The Earth is not moving around the sun, so you don't have any of those problems. We can't be thrown off, blown off, or anything like that. You don't have to keep the Earth moving. The stars are turning around the Earth. So we go back to what Ptolemy and Aristotle said. He said, though, that the sun circles the Earth, but the planets, other than Earth now, circle the sun. It's sort of a compromise. If I were to draw this, we have Earth at the center, we have the sun circling the Earth, and then the other planets circling the sun. 1, 2, 3, 4, 5. And he finds that by doing this, he is able to get good agreement with the old data, but it is no better in fitting the new data. He cannot adjust this and recreate the record of the planets that he himself had recorded. Well, you do the best you can, people. He finds that he can get a new model that agrees with the old data, but not the new. And generally, this becomes the accepted model of the universe, that the Earth is at the center of the universe, with the sun going around the Earth and the other 5 planets going around the sun. So it's kind of half and half. But he knows that it does not work as well as it should. This is the way it is. You do your best. You do your best. This is his best. Any questions or comments? Well, what happens next is, this is Tycho Brahe. Another person comes in who was interested in describing the motion of the heavens. And his name is Johannes Kepler, or Kepler. And he takes over the observatory around 1602 when Tycho dies.
What was Kepler's first name?
Say again?
What was Kepler's first name?
Johannes.
Okay, I'm moving this over. Thanks.
Thank you for asking. Tycho passes away. Kepler is looking to unlock the secrets of the universe, and he knows that if he's going to do this, he has to have access to data to prove or disprove his theories. So he introduces himself to Kepler, and for several years works for the observatory, works his way up, so that when Kepler passes away, he becomes the director in 1602. And what Kepler does is he tries to retweak all of the theories. So notice at this point in time, none of the theories that had come out could agree with the new data taken by the observatory. None of the theories at that time could agree with it. Not a single one. Including Kepler's own. Or, I'm sorry, including Tycho's own. Kepler keeps working at it, working at it, working at it, working at it. And finally, he says, he gives up. And he says, if I am constrained only to use circles, he might try using 3 circles, 4 circles, he might try all kinds of stuff. He cannot get it to work. And if you look at all of the theories that were known, the one thing that they all had in common was circles. Everybody insisted on using circles because, or combinations thereof, because that was the perfect shape. Kepler says, if I am only allowed to use circles, I cannot make it work. It will never work. So ultimately, he finally rejects the circle. This has been going on for 1,800 years or whatever. This is a brave move. He finally rejects the circle. And the problem is, if it's not a circle, then what is it? Fortunately for Kepler, he has a background in geometry. He has a background in geometry. He's also got a background in astrology, some other questionable stuff, which hurts his reputation, but, you know, let's not worry about that. He says it's not the circle or any combination of circles, it's got to be something else. It takes him 7 years. 7 years to finally figure out the shape. And in 1609, he publishes his first 2 laws of planetary motion. Now you might say, well, do people accept his laws? Of course not. Don't confuse me with anything new, or don't confuse me with the facts. My God, look at the situation we have now. People don't want to know the facts. They want to believe, you know. There are people that believe that there are only 9,000 COVID-19 deaths. They say because you die of a heart attack, because you had COVID-19, you really didn't die of COVID-19. I wish you'd tell that to someone's grandmother who passed away and the bereaving family about that. And tell them, well, it wasn't COVID-19, and besides, she was old anyway and had a bunch of diseases anyway, so who cares if she dies? This is the attitude of some of the people in this country. It's crazy. Well, you know what? That kind of attitude isn't new. People don't like the truth. People don't like reality. They reject it. But here's what he comes up with. The shape that he comes up with is a well-known geometric shape. It's so simple, it's disgusting. It's just disgusting, okay? I can take 2 points, like that, and a piece of string, and I don't know what I did with it. Anybody? Oh, there it is. And the piece of string, and let's move this over to there. What shape is that? Everybody says a circle. It is not a circle. If you measure this distance and this distance, they are slightly different. It's an ellipse. Now what if I put these 2 points truly on top of each other and did it? Then what would I get? Then it would be a circle. But if I have, these are called the foci, if they are not on top of each other, I get an ellipse. Okay? This is why it went unnoticed. It turns out that the orbits of the 5 planets that were visible, and also Earth, are ellipses, but they're almost circular. Casual observation makes you look like that they are circles. They are not. They're so close, you might not notice it. Now, if I put those points much further apart, if I make those points a lot further apart, well then it is obviously not a circle. That is obviously not a circle. That is an ellipse. And the first law of Kepler this is in 1609, is the law of ellipses. First of all, the sun is the center of the universe, not the Earth. It is a heliocentric model, but that does not mean that the sun is at the center of the ellipse. Here's the center of the ellipse. The sun is not at the center of the ellipse. The sun is at one focus of the ellipse. The orbits are ellipses. With the sun at one focus. Okay? All right? There's the first law. The planets do not orbit the sun in the perfect circle. They orbit in a circle which is longer than it is wide. Just like a square is to a rectangle as a circle is to an ellipse. All right? He also says they do not move at a constant rate like this. This is not how they move. He says that they speed up as they get near the sun and slow down further away, and speed up and slow down, and speed up and slow down in a very specific way. And that is the second law. The law of equal areas. This is the first law. And we got just enough time for our quiz, so we'll stop there. in the textbook, the way you can do this, we're in chapter 2, look up any of the things we've discussed here, look them up in the back of the book in the index. I'm not going to tell you read page so-and-so to so-and-so. Look up Kepler's laws in the back of the book in the index and read up anything about Kepler's laws. Look up Tycho Brahe, read about him and his model, and Copernicus and Ptolemy. Okay, to get to the specific pages, look in the index in the back of the book and that will tell you where to go. All right, we'll see everybody on